Number 2, to find the length of the missing side, we're going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So you have 8 squared plus 6 squared equals c squared. So it's 64 plus 36 equals c squared. So c squared equals 100. Square root of both sides. So c is equal to 10. So this is 10. Number 4, we're trying to find the length of the hypotenuse. So we have the Pythagorean theorem, 8 squared plus 15 squared equals c squared. So you have 64 plus 225 equals c squared. And we have the square root of 64 plus 225, and that is 17. So you have to get the square root of both sides. So c is 17, so this is 17. Number 6, to find the length of the side, and there's a hypotenuse, so we have 14 squared plus 10 squared equals c squared, and you want to live it in radical form, so you want to get the square root of both sides. So 14 squared plus 10 squared is going to give you the square root of 296. The largest perfect number that goes into 296 will be 4. So it's going to be the square root of 4 times the square root of 74, and this simplifies to 2, because the square root of 4 is 2, square root of 74. So to find the hypotenuse, it's going to be 15 squared plus 2 squared is equal to c squared. Find the square root of both sides. So c equals the square root of 225 plus 4.
Good morning, health professions. Please stand and join me for the Pledge of Allegiance and the Pledge of...
So c equals the square root of 299, and it can be simplified, so you leave it like that. Okay, we have to find the length of the hypotenuse. We know that this is a 45, 90 right triangle. So I know that you have a foldable describing this 45, 90. This leg is x, this leg is x, this leg, or this hypotenuse, is x squared root of 2. So this is 3 square root of 2. This is also 3 square root of 2 because the two angles are congruent, so the opposite sides are congruent. So this will be 3 square root of 2 times the square root of 2. I know it looks awkward, but that's the way it's going to be. 3 square root of 2 times square root of 2. So it's going to be 3 times the square root of 4, which is 3 times 2, which gives you 6. So that length is going to be 6. You don't have to memorize it. You'll have this in your interactive journal, so you can use it on this. Number 12, find the length of the leg. If your answer is not an integer, leave it in simplest radical form. So this is 45, this is 45, that's 90. Remember, you don't have to memorize this. You have that pamphlet, the foldable. So it's x square root of 2. So this will be equal to x times the square root of 2. And you notice we have an equation, so we can solve for x. So I'm going to do it down here. 24 equals x times the square root of 2. Divide this by square root of 2. Divide this by square root of 2. Let's see if this will do it. Let's see. 24 divided by square root of 2. Okay, it does give you 16.97. What you need to realize that you have 24 divided by square root of 2. So you got to multiply this by square root of 2. What I'm doing here is I'm simplifying. So square root of 2 times square root of 2 is square root of 4. And it's 24 square root of 2. You got to follow me. So the square root of 4 is 2. So 24 divided by 2 is 12. So each side will have to be 12 times the square root of 2. This will have to be 12 times the square root of 2. Okay. The length of a hypotenuse in a 30, 60, 90 right triangle is 9. So here's 30, 60, 90. The hypotenuse is 9. So there's my triangle. Let me go ahead and draw this again. So 30, 60, 90, that's 9. So remember, in a 30, 60, 90, you don't have to memorize it. This is the shorter leg because it's opposite 30. 60 is the longer leg, and this is the hypotenuse. The hypotenuse is always twice the shorter leg. And the longer leg is x times the square root of 3. So if this is 9, this is 4.5, because that's half of the hypotenuse. And the longer leg is 4.5 times the square root of 3. But the question was to find the perimeter. So to find the perimeter, you have to add 9 plus 4.5, which is 13.5, plus the radical, 4.5 times the square root of 3. So we have a 30, 60, 90 right triangle. Remember, you don't have to memorize anything. You have your foldable. This is 30, 60, 90. This is x. This is twice the x, which is that's a hypotenuse. And this is x times the square root of 3. So if this length, which is a hypotenuse, is 16 square root of 3, then y will be half. And you're probably wondering, how do you do that? Well, you just have to divide. 16 divided by 2 is 8 square root of 3. The value of x will be 8 square root of 3 times the square root of 3, because I'm following this the model there. So square root of 9 is 3, so 3 times 8 is 24. So this is 24. This is 8 square root of 3, and the hypotenuse is 16 square root of 3. Okay, so we're dealing with a special right triangle. That's 60, 90, 30. And here is what you have on your foldable. That's 30, 60, 90. This is 2x. This is x. And this is x square root of 3. You don't have to memorize this. This is a 30, 60, 90. So just look at your foldable. The hypotenuse is 16. The shorter side is half. So the longer side is going to be 8 square root of 3. And we're just following this model. Once again, you have a 30, 60, 90, and you have access to the foldable. This is 30, 60, 90. This is x. This is 2x. This is x square root of 3. So 30, this is the shorter leg. This is 60. This is 90. So the length of the hypotenuse is twice. So that's 24. The length of the longer leg is a shorter leg times the square root of 3. In this problem, we're missing the actual ratio. So in this case, you have to use the inverse tangent. And what goes in here is the angle. So the angle is 65. And so to find the ratio, because that's what you're trying to find the ratio, then what you do is you go to your calculator, go to trig. Now tangent, cosine, sine, these are the normal trig functions, but you want the inverse tangents. And so this is accepting the angle. So you type in the angle, 65, and then you have the ratio. Now you got to make sure that you're in degrees. So I'm going to go to menu, settings, document settings, and it is in degrees. Okay, so back, and I'm going to go to trig, inverse tangent, 65, and it says 89, so I'm going to write 89. It says nearest hundredth, so it's 89. 1 is tenths, and one more is hundredths, so I'm going to say 2. So once again, we have to find the angle, because it says find the missing value. So we're going to use the inverse sine, and what you're going to provide, the function is the ratio. So it's 5 over 19. And what comes out of here is the actual angle. And I already did it here. It says nearest hundredth. So the 5 is the nearest hundredth, so it's going to be 6. So it's 15.26 degrees. And once again, you go to trig, inverse sine, and just type in the ratio. You get 15.26. So 26, write the tangent ratios of angle P and angle Q. And remember I told you to memorize this statement. So, ka, toa. Also, you have an interactive foldable, so you can do this. You can look at the statements. You don't have to memorize it. So write the tangent ratios of P. So I'm going to write tangent of P. Tangent of P is opposite over adjacent. So I need to focus my attention on P. So what is opposite? 16. What is adjacent? 12. And if you can simplify, you need to do so. So the common factor is 4, so it's 4 over 3. So we did tangent of P. Now we got to do tangent of Q. So now we're not going to focus on P. We're going to focus on Q. So what's the opposite of Q? Is 12, right? And what is the adjacent? 16. They still have a common factor of 4. So you have 4 over 3. This was 3 over 4. So these two are the ratios. And P and Q are the angles. P and Q are the angles, so you know what's going on. And this is the mnemonic statement that I told you to memorize, but you do have a foldable describing it. Now we have to use the trig ratios to find the missing link. So we have so, ka, toa. So here is the angle. This is the adjacent side. And this is the opposite. So which is usually opposite and adjacent? It's going to be tangent. So you write tangent of 40 degrees, which is going to be opposite. In this case, it's 4 over the adjacent, which is x. So now this is a proportion problem. I told you in class to write a 1. And then you're going to multiply across. 1 times 4 is 4. X times tangent of 40 equals 4. The next thing that you do is divide by tangent of 40. So let's go to our calculator. So we have 4 divided by trig tangent of 40. So we have 4 divided by tangent of 40. This becomes 1. So mathematically we're left with x, and we have to divide that. So what do we have? Round to the nearest tenth, so it's going to be 4.8. Your interactive foldables, I forgot cosine. So katoa. So this is the angle that we're focusing our attention on. And compared to the angle, this is the adjacent side. And this is the opposite side. So you can use tangent. So you have tangent of 30 degrees equals, in this case, opposite is x. The adjacent is 10. So this becomes a proportion problem. So divide by 1. So 1 times x gives you x. And then you multiply 10 times the tangent of 30. So go to your calculator. 10 times tangent of 30. So the nearest tenth, so it's going to be 5.8. So once again, you have a right triangle. You're going to use SOHCAHTOA. You're going to focus your attention on the angle. This is the hypotenuse, and this is the adjacent. Once again, it's going to be cosine. So you write cosine of 32 degrees equals the adjacent, which is 12, over the hypotenuse, which is x. So now you make these into two fractions by putting a 1 here. And just like you did in solving proportions, you're going to multiply 1 times 12, which is 12. And then you multiply x times the cosine of 32. So you're going to divide by the cosine of 32, divide by the cosine of 32, and that will give you the length to the nearest tenth. So you have 12 divided by trig cosine of 32. And that's going to be 14.15. Yeah, just get in the habit of writing the mnemonic statement. So it's SOHCAHTOA. It's a right triangle. We focus our attention on the angle. And that's the hypotenuse. And that's the opposite. So we're going to use sine. So we have sine, because that's opposite of hypotenuse. Sine of 20 degrees. The opposite is 19. The hypotenuse is x. So I'm going to go ahead and write a 1 underneath sine of 20. And what I'm going to do is I'm going to multiply across. So 1 times 19 is 19. And x times the sine of 20 is x times the sine of 20. So we want to isolate x, so we have to, since we're multiplying, we're going to divide by sine of 20. So go to your calculator. So you have 19 divided by trig sine of 20. In this case, it's 55.55. Okay, so it's a right triangle. So just get in the habit of writing this statement. So, ka, toa. This is the angle. So we're going to write, this is the hypotenuse, and this is the adjacent, right? So we have the adjacent and the hypotenuse. So we write down cosine of 30 degrees. The ratio is adjacent to the hypotenuse, so it's going to be 9 over x. And since we want to make it into two fractions, we put this a 1. Now we're going to go ahead and multiply across. 1 times 9 is 9. And then x times the cosine of 30 degrees is equal to 9. You want to isolate the x, so you have to divide both sides by the cosine of 30 degrees. Divide by the cosine of 30 degrees. Go ahead and get your calculator here. So you have 9 divided by trig cosine of 30. And you round off to the nearest tenth. So x equals 10.39. 38 is a right triangle. So once again, write down your mnemonic statement. So katoa. We look at the angle. This is the hypotenuse. That's the opposite. So we're looking at sine. Sine of 38 degrees is equal to opposite, which in this case it's x, over the hypotenuse, which is 16. We write a 1 here. So now we have two ratios. We're going to go ahead and cross multiply. 1 times x is x. 16 times the sine of 38. So it's 16 times the sine of 38. So we're going to write, we're going to type in our calculator, 16 times the sine of 38. So it's 9.85. Number 40 is different because you're missing the angle. So you got to use so, ka, toa. So we're still focusing our attention on the angle. This is the opposite, and this is the hypotenuse. So it's going to have to be sine so. So we have sine of x equals opposite, in this case it's 12, over the hypotenuse, which is 15. And you're missing the angle, so you're going to have to find the inverse of this ratio, which is 12 over 15. So go to your calculator, trig inverse sine. So it's 12 over 15. So the angle is 53 degrees. So this one was different because you were trying to find the angle. What is the description for angle 2? So if you look at the tower, this would be considered the angle of elevation. So from the tower's perspective, it's the angle of elevation. Find the value of x. Well, you know that this line is parallel to this line. So this is 40, this is 40. So that could help us out in figuring out the value of x. This is the hypotenuse, and this is the opposite. That's the opposite hypotenuse. So we have so, ka, toa. So which uses opposite hypotenuse is going to be sine. So you write sine of 40 degrees equals the 500 meters divided by x. So remember to place a 1 underneath this to make it a fraction. So you have x times the sine of 40 degrees is equal 500 times 1, which is 500 meters, divide by the sine of 40 degrees, divide by the sine of 40 degrees. So let's go to your calculator. So you have 500 divided by the sine of 40 degrees. And so the length of the hypotenuse is, and you have to round to the nearest tenth, so it's 700. So the length of the hypotenuse is 777.86. meters. To approach the runway, a pilot of a small plane must begin a 10-degree descent starting from 1983 above the ground to the nearest mile. How many miles from the runway is the plane at the start of the approach? So right now it's in feet. So we got to make sure we understand it's in feet. That's going to be 10 degrees. And this is a hypotenuse. So we have that's hypotenuse is opposites. Remember what I told you to always place SOHCAHTOA. So you know it's sine because it's a hypotenuse and opposite. So you write sine of 10 degrees is equal to 1,983 feet divided by x, and you place a 1 here. So you're going to multiply x times sine of 10. So x times sine of 10 equals 1,983 feet. So now we will divide by the sine of 10 degrees. Sine of 10 degrees. So we have 1,983 divided by the sine of 10 degrees. So that's x is equal to 11,419 of 0.6 feet. There's 5,280 feet and 1 mile. So what you're going to have to do is you're going to have to divide 11,419 divided by 5,280. And so approximately it's 2.2 miles away. Find the length of the leg. If your answer is not an integer, leave it in simplest radical form. So this is 30. Remember the foldable? 45, 45, 90, x, x, x square root of 2. So what you have is x square root of 2 is equal to 30. This is a hypotenuse. This is a hypotenuse. So you divide by the square root of 2, and they want it in radical form. So you're going to have to multiply by the square root of 2. So it's 30 square root of 2. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So the length of each side will be 15 over 15 square root of 2. So this is 15 square root of 2. This is 15 square root of 2. Number 50, the length of the hypotenuse in the 30, 60, 90 is 8. I'm going to draw a 30, 60, 90. 30, 60, 90. And this is what you have in your foldable. 30, 60, 90. This is 2x. This is x. This is x square root of 3. The length of the hypotenuse is 8. So this will always be half. So that's 4. And the longer leg, if you notice, it's going to be x times the square root of 3. So it's going to be 4 times the square root of 3. And if you want to find the perimeter, you're going to add 4 plus 8, which gives you 12. Plus, you can't add the radical in that form, so it's going to be 4 the square root of 3. That's the perimeter. Find the missing lengths. Find the lengths of the missing sides of the triangle. Write the answers as integers or decimals round to the nearest tenth. So that's 45. This is 45. And you don't have to memorize the 45, 45 interactive foldables. This is going to be x, x, x square root of 2. So this distance is actually 9, and this is going to be 9. So x is 9 square root of 2. Find the missing length, the missing value in the nearest hundredth. So we don't know what x is. So you're going to have to use the inverse tangent. You provided the ratio. So let's go to trig here. Inverse tangent and type in 48. That's the ratio. So the angle is going to be 88 degrees. So this one you will have to use the inverse tangent. 56, find the missing value of the nearest hundredth. So once again, you have x is equal to You have sine of x is equal to 4 over 27. So you have to use the inverse sine. Since you're using the ratio, this is actually the ratio, and you're coming up with the angle. And the angle is in degrees. So we're going to go to trig sine. So you have 4 divided by 27. And so the angle is 8.52 degrees. So we need to write the tangent ratios of angle P and angle Q. So we're going to write the mnemonic statement, which is so, ka, toa. So we go to P. So tangent is opposite, which is 12, over 16. This is opposite. This is adjacent. Divisible by 4, so it's 3 over 4. Q, tangent of Q is opposite, which is 16, over adjacent, which is 12. And it's going to be the reciprocal, it's going to be 4 over 3. So this is tangent of P, and I forgot to put P there. So once again, we're dealing with a right triangle. Write the ratios of sine of A. So sine is so, cosine is ka, and then we have toa. So you write sine of A is opposite. So in this case, opposite is 63 over the hypotenuse, which is 65. The next one is cosine. So cosine is adjacent. In this case, this is adjacent, and this is your hypotenuse. So adjacent is 16 over hypotenuse, which is 65. And I think you can simplify the first one. I think it's divisible by 3. No, it's not. No, it's not divisible by 3. So we leave it like that. So which graph gives the transformation? And they have -4, 2. This means to move to the left, and this means to move up. So let's use our logic here to eliminate answers. D is eliminated and B is eliminated because they're both going up. The only one going left is A, so that has to be our answer. Find the translation rule that describes from B to E. And of course, you notice that the x's stay the same, so that's 0 because it doesn't move in the x direction. But it does move up. The question is, how many units does it move up? So you have to add -8. You have to add something -8 to get you to 15. So you have to add 23. You have to add 23 to -8 to get 15. So all I did is I added 15 plus 8. So I have 23. So 23 plus -8 gives you 15. Describe in words the translation of x represented by the rule -2, 8 of x. Okay, so what you're gonna do, you're gonna move x 2 units, move x 2 units to the left, and 8 units. So that's the description in words. You move x 2 units to the left, and units up, 8 units. Use a translation rule to describe the translation of P, 6 units left and 6 units down. So it's going to be T, and so if you're going to go left, it's -6. If you're going to go down, it's -6. And then what you're going to do is you're translating P. So you're going to go 6 units left and then 6 units down, and that's P. Okay. The length of a hypotenuse in a 30, 60, 90. So I'm going to draw 30, 60, 90. The hypotenuse is 7. So this is 3.5. This is 3.5 square root of 3. So the perimeter is 10.5 plus 3.5 square root of 3. The length of a hypotenuse in a 30, 60, 90. So I'm going to draw the 30, 60, 90. 30, 60, 90. The hypotenuse is 4. So this distance is 2. It's always half. And this will be 2 square root of 3. So to find the perimeter, you need to add all sides. So it's going to be 6 plus 2 square root of 3. A triangle has the lengths of 24, 143, and 145. Is it a right triangle? So it's going to be 24 squared plus 143 squared, and you got to check it if it equals to 145 squared, and so I'm going to pause it for now. So it's not true. I just checked, so it's not a right triangle. And so the other two is the same thing. So you're going to have to add, you're going to have 26 squared, and you have to compare it to 10 squared plus 24 squared. So I'm going to go ahead and do that. 26 squared is 676. 10 squared plus 24 squared is 676. So this is a right triangle. It's a right triangle. And then 80 is 28 squared. So I'm going to write 28 squared. And you got to compare it to 23 squared plus 6 squared. Okay, so 23 squared plus 6 squared. Okay, it's less. In other words, 28 squared is greater. This is obtuse. So we're going to have a dilation of 2 about the origin. So what you're going to have to do to the x and also the y, you got to multiply by 2. So a prime is negative 2, negative 2. B prime is negative 2, 1. C prime is 0, 2. And D prime is 2, 0. Negative 2, negative 2. That's A prime. B prime is negative 2, 1. That's B prime. 0, 2. That's C prime. And D prime is 2, 0. So this is a non-rigid transformation. That's what you got to remember. It's non-rigid. And it's a dilation. It's an enlargement, right? It increases. And the scale factor is 2. So we're doing a dilation of 2 about the origin. So we have A, B, C, and D. I have the ordered pairs here. What I did is I multiplied by 2. I graphed them. What I want you to remember, there's a non-rigid transformation. It's an enlargement. It's a scale factor of 2. So I'm going to go ahead and list the ordered pairs. So this is negative 2, 1. B is 1, 2, 2, 2. And C is negative 2, negative 1. I'm doing an enlargement, a scale factor of 2. So A prime is negative 4, comma 2. B prime is 4, comma 4. And C prime is negative 4, negative 2. So A prime is negative 4, 2. That's A prime. B prime is 4, 4. That's B prime. And C prime is negative 4, negative 2. That's C prime. Connect the points. And there's the enlargement. Translation, the rule is you go 3 to the right and 1 down. So here's G, 1, 2, 3. Go down 1. So this is G prime. So it's going to be 1, 1, 2, 3. 1, 3. So that's G prime. F prime, 1, 2, 3, down 1. So it's going to be negative 2. No, negative 2. This is going to be F prime. F prime. You go over 3, 1, 2, 3, down 1. It's where G used to be. So it's going to be negative 2, comma 4. And then E prime, 1, 2, 3, 4, down 1. So that's E prime. So it's 0, negative 1. Connect the points. And there is our translation.